Hi everyone. Today we're going to go over 3.2 notes. This is the only section of Unit 3 that you guys will have. With that in mind, you will have a quiz first thing next class on the material that we are about to cover here in just a second. Okay, so we're going to just make this a quiz and then we're going to jump into Section 4, Unit 4, and we'll have our test on just Unit 4 next. All right. So for 3.2 notes, you have your notes in front of you. However, the vocab is not listed. So go ahead and either find a spot on the note page to write the vocab or find a spot in your notebooks to write these down. There's only 3 examples for the vocabulary. So we will just talk about those 3 and then be on our way. So chapter 3.2 is on linear functions. We've already talked about linear functions all through Unit 2. The test that you just took was on linear functions. More importantly, it was on line functions. Okay, those functions included slope-intercept form and point-slope form. So we're going to be talking about that more throughout these notes and throughout Unit 4's notes as well. So to get started, we have the vocab word function notation. All right. From here on out, you might see function notation throughout Algebra 1, Geometry, Algebra 2, and even Trig. So what function notation is it's writing a notation as a function of other variables. So if I took this and I basically put it in my own words, essentially what's happening is we're going from a y equals statement. We've seen all of our linear examples to say y equals this, y equals that. It's now going from y to f of x. That's what we call that, f of x. Essentially the parentheses are of and then x. So you're giving me a function, that's what f is, a function of the variable x, hence why it's called function notation. And right below that, you have this example here. So we have y equals 5x minus 1, but all that has now changed is this f of x. The only thing that's been flip-flopped has been your y. So y has now changed to f of x equaling 5x minus 1. And the great thing about this is now we can compare our x values with our y values. That's why function notation is very helpful. And we will get some practice on that today. Then we have a linear function. And a linear function is a function whose graph is a straight line. Linear, think line. Linear function, think line. And if you remember from our section of notes last unit, okay, we talked about 2 forms of a linear function. We had 2 forms, and those forms were y equals mx plus b. And the name for that was called slope-intercept. Slope-intercept form. Again, it's still a linear function. At the end of the day, if I were to graph that function, that slope-intercept form, I would still have a line. That's what designates a linear function. And then the second form was y minus y1 equals m, parentheses, x minus x1, which was called point-slope form. Again, if I were to graph point-slope form, I would be able to make a linear function, a line. And then we have what's called an H-chart. And the H-chart is what we're going to make for the rest of this section, and really the phrase starts now. When in doubt, graph it out. And if you forget how to graph, if you forget your slope and your intercept or your point and your slope, if you forget any of that, we can always make an H-chart. And so an H-chart will look exactly, kind of like an H. So we will have 3 columns and then 2 rows. And the top left is going to be x, and those are going to represent our x values all the way down. And then on the inside here, we're going to have our section for work. And then on the last here, we will have f of x, otherwise known as our y values. All right. Now, as we make this H chart, we will always have the same 5 x values. We call those inputs. They're going to be the values that we're plugging into the equation. Those 5 values we will stick with are -2, -1, 0, 1, and 2. All right, now why did I choose these values? They're just easy to work with, especially with the calculator. All right, we could choose numbers like -5 and -6 and +10 and +154. But at the end of the day, if we stay small, we can work with these values just fine. So I'm going to stick with -2, -1, 0, 1, and 2. All right, always, 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 we are going to use these values. Then when we look in the work section, we are also going to add the fact that we need to replace every x with, and I'm going to put parentheses. So in the work section, we'll get practice with this here in a second, but in the work section, every time you see x, you're going to replace it with just parentheses. You're not even going to write x any longer in that middle section. And then for the f of x, those are going to be our outputs, meaning those are what the value is coming out. So we're going to work left to right. You start with your x values, we plug those into the function, and then on the right side is the value that we get out. And those inputs are going to give us coordinates. And if you know what coordinates are, it's your x and your y value. So we get the x from the section all the way on the left here, those -2, -1, 0, 1, and 2. And then in order to get the y, it's all based off of what comes out in the f of x section. So we'll get plenty of practice on that today. All right. So if you look down at question 1, or example 1, it says evaluate each function for x equals 6. So for starters, it asks us to evaluate, so we're literally just solving, we're plugging it in, we're evaluating the function, and then it says for x equals 6. So it literally told us what x has to be in order for us to evaluate. So when I look at questions A, B, and C, the only thing I'm going to switch out is an x, and the thing I switch out my x with is a 6. Now, I can't just make switches on the fly, I have to also use parentheses. And the reason for this is because if I switch out my x's, take a look at what happens here. Let me use the same colors so we can pay attention to what's happening. If I switched out this x right here with a 6, when I read this problem now, it now looks like -26 minus 3. But if you were to read this problem to me out loud, you would say -2x minus 3. And when you say -2x, you would tell me that the operation that's happening is multiplication. So in order to remember and keep track that this is multiplication, I have to use parentheses. Whenever you replace something, always be sure to use parentheses. And now we can use our calculators and we just solve. So the g of 6 is going to stay on the left-hand side. Okay, g of 6, it's a function of 6. This time it's g instead of f, but it's the same idea. All right. And then -2 times 6 gives me -12 minus 3. And if I work down once more, that tells me that g of 6 equals -15. And what that means is that when x is 6, you're going to get a -15 out of this function. All right, more importantly, this tells us a coordinate now. And that coordinate is always the x value that you used. So we're going to say 6 in my x position. And then the -15 will now be my y value. And so based off of plugging these values in, I can find coordinates. And when I have coordinates, I can then make my graph. All right, so I'll show question B, and then you will do C on your own. So same thing, H, this time again, you're plugging in 6 every time you see X. Make sure you use those parentheses so you don't think that says 76, because that's going to be too big of a number that we want to work with right now. You get a 42 plus 15, and that gives us a 57 at the end. So remember, the H of 6 is just going to drop down. Nothing's changing with that as we go. All right. But what you're telling me now is that when X is 6, your function is going to come out to 57. So the reason why it came out to a different value this time as opposed to question A is because it's a different function altogether. So it's a different line. This line is going to have a different value when X is 6. So go ahead and pause this video and attempt question C. And when you pause this video, you will practice, again, plugging in 6 for x. Use your parentheses. Yes, you will have 2 sets of parentheses here. That's going to happen. That is quite okay. Solve using PEMDAS. Worry about the parentheses first. 6 minus 4 is going to give me a 2. And I still have that negative out front. And when I apply the negative, I still have a negative 2. So this time, when my x was 6, I got a negative 2 out. Okay. So now when we move down to example 2, we've practiced plugging values in. So now when we get to example 2 and practice A, B, C, and D, we're going to have the same exact scenarios. We're plugging values in. But this time, I'm not going to remember, or I'm going to assume I don't remember that we're talking about slope-intercept form. Okay, I know questions A and B, looking at those, they are in slope-intercept form. I know I can identify my intercept and I can identify my slope. But what if I forget? What if the day of my final, I forget how to do that? All right, you can always, always, always make an H chart. And that's what we're practicing today, is these H charts and plugging them in. So if I forget what my slope is and how that applies to my graph and how my intercept goes into my graph, I can create an X chart, or excuse me, an H chart. So again, I'm going to start with X. It's going to be 3 columns. And I'm going to leave the most room in the middle here, if that's my work. And then the last column is going to be my f of x. So before I get started, I have my x column, that middle column that I haven't filled anything in yet, and then my f of x column. So right now, when I fill in this middle column, I'm going to fill it in with the exact same function as I see. Okay, more importantly, I'm going to fill it in with this section here, the actual equation. But every time I see x, I'm replacing it with parentheses, just like I said in the vocab. All right, so picture it like a box, if you will. We don't know what that x value is, so we're going to put parentheses around it, and as we go through the following H chart, we will replace that parentheses with the values that we're working with. And if you remember, on your x column, we're using the same 5 points. -2, -1, 0, 1, and 2. And all you're doing is you're taking that x value and you're plugging it into the work on all of these problems. So I'm literally writing the same thing over and over and over again. Kind of ran out of space here. I'm sorry, it kind of gets jumbled. You're plugging all of your x values in each section. So the first one's going to be -2, second one's going to be -1, then 0, 1, and 2. By already replacing your x with parentheses, you know exactly where to replace your x value in all of these, which is really, really nice. And then I have that calculator with me, so I'm going to work these out. You have a negative, parentheses, -2 plus 1. Now the beauty of this is your calculator has parentheses, your calculator has negative buttons, so you literally just need to type it in exactly as you see it. So practice that. Negative, find the parentheses. Remember that negative button's in the bottom right? It's that white key to the right of 0. Make sure you're choosing that as your negative, not a minus sign. So we have negative, find your parentheses, -2, parentheses, plus 1. And when you hit enter, the answer that you get out is going to go in the f of x section. And that's going to be a 3. I continue. Negative times -1 plus 1 gives me 2. A negative times 0 plus 1 gives me 1. And a -1 plus 1 gives me 0. And last but not least, a negative times 2 is going to give me, oh, I typed that in wrong apparently. Yes, I did. That should be a 1. There we go. Okay, so now a -2 plus 1 should give me a -1. So if you look at your f of x's, you're actually decreasing all of your values by 1, which is good, all right? But now we can take these values and we can make them coordinates. So at -2, 3, I have my first point. -2, I'll use red here, -2, comma 3, that's my first point. Same thing going forward, -1, comma 2, I have my next point. Same thing, 0, comma 1, and you'll see that your line is starting to form, 1, comma 0. And everything is labeled for you. You know exactly what your x is, you know exactly what your y is, so you just need to plot them. You have all your dots, connect your dots with a line with your arrows in the corners. So again, if worse comes to worse and you're on your day of the final or your day of this test coming up and you don't remember your slope-intercept form, you can always make a H-chart, okay? Always use the values for x followed by your values for f of x. So I'm going to go ahead and pause, or you go ahead and pause. You're going to try B, all right? Go ahead, try B on your own and see how we do. Same thing, plugging in our values. This time your work is going to be 3 parentheses plus 1. Same 5 different values for x. And you're plugging in everything as you go. -2, -1, 0, 1, and 2. Using that calculator, you will get a -5 to begin with, -2, a 1, a 4, and a 7. So when I go to graph these, I'll use blue this time. I have -2, -5, -1, -2, 0, 1, 1, 4, and then when I get to 2, 7, it's going to be off the grid, which is fine. And the reason that's fine is because I have plenty of points to make my line already. So I don't actually have to graph 2, 7 because I got 4 other points that I can connect and still make my line. Okay, if you didn't have enough points, then I would advise you to make more points and plug in more values for x. But for right now, we shouldn't need to. All right, same thing for question C. Try that one on your own. I'm actually going to skip C in this video, but as always, it will be posted. So if you want to check your work, it is posted in Teams under the Files tab for Unit 3 and 4. So if you want to take a look there, you can pull that up and check your work. All right, same idea. For question D, however, take a look at just the function. The function is just -1. All right, again, we're assuming we don't remember our slope-intercept form. So I'm going to make my H-chart. I have x, then the last section is f of x. But then when I get to the work, I still have -1, but do I have any x's that I need to put parentheses in for? There's no x here with my -1, so what's going to end up happening is that when I plug in my x values, nothing is going to change because there is absolutely no x value in here that is going to change it. So I can go directly to graphing each one of these coordinates, and you will see that when you graph them, you're actually going to have a horizontal line. And if you remember your slope-intercept form, that means that you had no slope, you just had an intercept. That's another way to remember how to graph if you forget slope-intercept form. You can just plug in your x values and see what you get out. And in this case, there were no x values to switch out, so our function will stay the same. All right. Question 3. Again, we have 2 examples here, okay? Example 3 says to write a linear function. Think about the vocab word linear function, all right? We have 2 forms that we learned last unit. We had our slope-intercept form, which was y equals mx plus b. And we had our point slope form, which was y minus y1 equals m x minus x1. All right. Well, if you look at this table here, you have your x column, or excuse me, your x row, and your y row. But if you look down, so if I combine these two together, it's the same as saying the coordinate 1, 6.5. Your x was 1, your y was 6.5. So I'm going to do the same thing with this second one here, 2, 13. And I could do the same thing with the other 2 points as well. But remember, we're writing a linear function. All right, so we either want to put it in slope-intercept form or point-slope form. So think about what you have right now. You have 4 different points, and we don't necessarily have an intercept right now, and we don't have a slope right now. But with these 2 points, I can find my slope. And if you remember, that slope is based off of the slope formula. Again, that was in our last test, our last unit. y2 minus y1 over x2 minus x1. So I can label my x and my y's. My first point's going to get the 1s, my second point's going to get the 2s, and now I can plug in my values I just labeled. So y2 was 13, y1 was 6.5, x2 was 2, x1 was 1. And so right now my slope is looking to be 6.5 over 1. So I have my slope, that's what I just got. I had a point that they just gave me, so if I think about it, I have a point, I have a slope, so together I can put it in point-slope form. And just like last unit, all I'm doing is replacing the values I just found. So your y1, again, you just labeled it. It's going to be 6.5. Your m you just found, which was also 6.5. And then your x1 was 1. So when I ask you for a linear function, and I give you this as an answer, it does count as a linear function because at the end of the day, it's in point-slope form, and if I were to graph that, I would create a line. Okay? I went through that one pretty quickly. Again, this should be extreme review. It's just a different way it's being presented to you, but you still have 2 points. The extra stuff is just added information that's just useless for you, okay? They're trying to trick you when they give you questions like these. So if you took your coordinates and you wrote them down exactly as you like to see them as pairs, then you can find your point, find your slope, and solve. So go ahead and pause from here and try finding your slope and then plugging it into your point-slope form. So my slope is going to be a 3, and if I plug it into point-slope form, I will have y minus 1 equals 3 parentheses x minus 1. And you're all set from there. All right. For example 4, for the last example of the day, again, read the directions. The directions are asking for 5 coordinates that work with the following functions. All right. Well, think back to when we made those H charts in these examples. How many coordinates, how many points were we able to plot with the values I chose on my H chart? Okay. I had 5 points. On question B, I only had 4, but really I could have had 5. It's just the 5th one didn't fit. But I can get 5 points based off of the same 5 x values that I had on the H chart. So for question 4, example 4, I'm looking for the same thing. You can make that H chart and you can solve. Now, if you look at the first 2 on the left-hand side, those are in point-slope form. And then when you look at the second 2 on the right-hand side, they're in a little bit different form. So I'm going to solve the top 2, and then you will solve the bottom 2 on your own. Okay? So same thing. You're going to make that H chart. And really, actually, let's go back a little bit. What I want us to do first is I want us to simplify this, okay? First of all, it's not in function notation. It doesn't say f of x. It just says y, all right? But I want it to just have y on one side. So how can I move that 2? I want to add 2 to both sides. And when I add it to the right side, I have to put it at the very, very end. So really, my function is y equals 2 parentheses x minus 3 plus 2. And then think about what we did from here. This is going from point slope, and we're going to end up putting it in slope-intercept form. So if I continue, before I even worry about the 5 coordinates, I want to get it in a way that's going to make sense, an easier way for me to plug in these numbers and not have to do so much work in the calculator. So I'm going to distribute. That gives me 2x minus 6, and then I still have this plus 2 at the end. I get to combine my like terms, negative 6 and 2, because they don't have any x's with it, and they're both constants. So really, my function right now is 2x minus 4. Okay, so all you have done right now is converted this problem into slope-intercept form. But the question didn't ask you to convert it to slope-intercept form. It's asking for 5 coordinates. But now that we have it in this form, I can make my H chart, and my work section is going to be 2 parentheses minus 4 followed by my f of x. So I can find those 5 coordinates. Same 5 values on the x. Get in the habit of using these. It's so much easier than using bigger numbers. All right. And then we're replacing every parentheses with the x value that we were working with. All right. So if I plug in a negative 2, a negative 1, 0, 1, and 2, use the calculator. You have it. It has parentheses values. It has the negative sign. Use that to help you. The first one, you should get a negative 8. Followed by negative 6, negative 4, negative 2, and 0. So when I ask you for the 5 coordinates, we want to put them in coordinate form. So we have negative 2 paired with negative 8, negative 1 paired with negative 6, 0 paired with negative 4, and 1 paired with negative 2. And last but not least, 2 paired with 2. So your final answer should be written as coordinates because the question asked for such. All right. For the second one, moving to the right here, we have 3x plus y equals 8. Again, this is not in slope-intercept form, so let's practice moving it into slope-intercept form. I want y all by itself, which means I have to take that 3x and move it, and I'm going to move it by subtracting. And if you remember, we want our x term to go in the front of that constant. So I want to subtract it in the front of 8. And we will get y equals negative 3x. And that 8 was positive, so by keeping it positive, I'm going to put a plus sign. Now we have it in slope-intercept form. And now I can make my H chart. Oopsie. My H chart. And let me go down here. There we go. F of x. All right. And then your work section has negative 3, parentheses, 8, plus 8. Plug in your 5 values for x. Use that calculator if you need to. Please use it. You have it, so let's use it. And then we will plug in our x values for each one. And if you do the first one, it should come out to give you a positive 14, followed by 11, then 8, 5, and 2. So the 5 coordinates you will submit is negative 2, 14, -1, 11, 0, 8, 1, 5, and 2, 2. So you're using that H chart to find your coordinates. H charts are very, very, very helpful. When in doubt, graph it out. And if you're still in doubt, make an H chart. All right. The last two questions are very similar to the ones right above them. So go ahead and try those on your own. If you need more space on your paper, just get out a piece of scratch paper so you have lots of room to work with. All right. Again, the answers are posted on Teams. They are in your Files tab, and under that you will go to Class Materials, Unit 3 and 4, and you will see it in the Teacher Notes folder that is in there already. Okay, so give these a try. Compare with a partner if you need to, and go from there. But that is your practice for today. Tonight you have a homework assignment, section 3.2, that has opened in Teams already. Go ahead and try that. Give it a shot. It is due on the 26th, so next Monday is